Now we want to analyze the sine using the concept of torque, and this video is advanced, so please don't look at it unless you are extremely crazy and curious like I am. We just explained that if a force is applied like this, it's going to create a torque, create rotation, and this force is actually now if the force is applied with an angle like this, then the only the y component of this force, the force perpendicular, actually only the force the component perpendicular to the lever arm is causing the torque for me. So this would be F sine theta. If, of course, the theta is the angle that the force makes with the lever arm. Now look at here. The bigger the force gets, I show it in here. The bigger actually, no, let's say, sorry, the force is the same size. The bigger the angle gets, the bigger the sine gets. Therefore, the bigger the F sine. So if now in here, as you can see, F sine theta is bigger. So the torque creating component of the force gets bigger until theta is the 90. So if theta turns to 90, then I have the maximum sine. So if my force is applied actually like this force, then the whole thing and these are the same sizes, so the whole thing would be causing the torque and is the maximum. So as you can see in here also, this theta has this much sine. Yeah, this is sine of theta. So let's say theta gets bigger. As it gets bigger, the sine gets bigger. Yeah, sine of theta gets bigger. And when the theta is 90, the sine of 90 is actually, when the theta is 90, the sine of 90 degrees is 1, which is the maximum sine. So of course the sine is a fraction smaller than 1, and the maximum of it is actually 1. Now some students might ask, what if theta gets bigger than 90, which is in this case? Look at here, the theta gets bigger than 90, then the sine gets actually smaller. It gets smaller again. So as it gets bigger, as the theta gets bigger than 90, bigger and bigger, the actually it gets here, sine gets even smaller. So if I apply my force here, as I did in here, which was my theta, theta gets bigger and my torque gets bigger, and if theta gets bigger than 90, my torque again gets smaller. And let's look at this situation actually. Look at this situation when the same amount of F is applied, but in this direction, and imagine this is exactly theta. What will happen in this case? As you can see in here, the Fy would be in the purple situation and in the red situation. In both of them, the Fy, which is causing the torque for me, is the same, is equal actually. How can I explain this concept? Yeah, you can see that this is same. F sine theta, F sine theta, and F sine theta in both situations are actually the same. Why is that? Remember this that you have learned in your math, your trigonometry. This is theta, and this one, this angle, which has exactly the same thing here, is actually should like this. It's actually 180 minus theta. So this is 180 minus theta. This is theta, right? So sine of 180 minus theta equals sine of theta. And you know that this is the same thing in reality. If this is your end, if you want to push it like this or like this, doesn't matter. Always this component is the one that actually causes a torque for you. This is why in problems, when you want to solve problems, you only consider this triangle actually, and doesn't matter which way the triangle is looking at. This triangle or this triangle. In both of them, the sine of theta, which you calculate, is associated with this opposite to the angle, which gives me this. In both cases is the same. So you only consider the triangle, but you know and you understand the sine concept in the unit circle. Now students might ask, why is that? What if the angle gets even bigger than 180? For example, if this is my theta, the theta actually increases, passes 90 and passes in 130 and goes here. Sorry, 180, passes 180 and actually goes here. What would happen in that case? Okay, imagine that my force is applied like this. Of course, I know again, if this is my theta, of course I know this is the component that causes the torque for me. Definitely causes the opposite direction. In all of these, the torque, the rotation is this way. In this one, the rotation is this way. The rotation is this way in this one, right? Because the F sine theta is here. And if I want to show it in here, it's actually sine of 180 plus theta, which is equal to, if you call this theta, imagine the angle is exactly the same angle theta. Of course, you know the sine is here, whereas for this one the sine is here. So this would be the same amount but the negative. So this would be negative of sine theta, right? This is why the rotation, the direction of the rotation would be negative. And it would be the same if your force is applied, like the force which was previously applied this way is now applied this way. So imagine this force with the same theta but negative theta. Of course the F sine theta would be here and it would cause negative. So just like as I can see in here, this is negative theta. This is negative theta, and sine of negative theta is negative sine theta, as I know in my unit circle. I can see that, and I have explained it before. So you have learned it in trigonometry, and so this is what we have. I'm just going to show this in this diagram. This would be actually 180 plus theta, and this would be negative theta in all of them. So this is why they say counterclockwise, if this is a seesaw for example, the counterclockwise is a positive torque and the clockwise is the negative torque.